everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. S.N.S. Rajalakshmi College of Arts and Science. In this series, we are discussing about the intelligent system and robotics. In this class, we are going to see about what is AI, that is, what is artificial intelligence. So in general, it means machine that exhibits some characteristic of intelligence. There are thinking, reasoning, planning, learning and adapting. It can also mean a software program that can simulate thinking or reasoning. Next, we see the artificial intelligence and advanced robotic techniques. So here we are using some of the techniques. We will see one by one. First one is the artificial neural network. That is, we start with object recognition. We need our robot to recognize objects and then classify them as either toy or be picked up or not toy to be left alone. We will use a trained artificial neural network to recognize object from a video camera from various angles and lighting conditions. So the next task is once a toy is identified is to pick it up. Writing a general purpose pick up anything program for a robot arm is a difficult task involving a lot of higher mathematics. That is a Google inverse mathematics to see what I mean. What if we let the robot sort this out of for itself? We use genetic algorithm that permit the robot to invent its own behavior and learn to use it on its own. Next one is a natural processing language. So our robot needs to understand commands and instruction from its owner. We use natural processing to not just recognize speech but understand intent for the robot to create goals consistent to what we want it to do. We use a neat technique called the fill in the blanks method to allow the robot to reason from the context of a command. This process is useful for a lot of robot planning tasks. So the robot task problem is avoiding the stars and the hazards. So we will use operant condition to have the robot learn through positive and negative reinforcement where it is safe to move. So that is the operant conditions. The next technique is a decision tree. So the robot will need to be able to find the toy box to put them away, as well as have a general framework for planning move into the future. We will use decision tree for path planning, as well as discuss pruning for quickly rejecting bad plans. We will also introduce forward and backward chaining as a mean to quick plan to reach a goal. If you imagine what a computer chess program algorithm must do, looking several moves ahead and scoring good moves versus bad moves before selecting a strategy. That will give you an idea of the power of these techniques. This type of decision tree has many uses and can handle many dimensions of strategies. So these are the things about decision tree and forward and backward chaining. The next one is artificial personality. I have 4 wonderful, talented and delightful grandchildren who love to come and visit. We will be hearing a lot of about them throughout the book. The oldest grandson is 6-year-old and artistic, as is my granddaughter, the third child. I introduced the grandson William to the robot and he immediately wanted to have a conversation with it. He asked, "What's your name and what do you do?" He was disappointed when the robot made no reply. So for the grandkids, we will be developing an engine for the robot to carry on a small conversation. We will be creating a robot personality to interact with children. William had one more request for this robot. He wants to be tell and respond to knock-knock jokes. While developing a robot with actual feeling is far beyond the state of the art in robotics or artificial intelligence today. We can simulate having a personality with a finite state machine and some Monte Carlo modeling. We will also give the robot a model for human interaction so that the robot will take into account the child mode as well. I like to call this type of software an artificial intelligence personality to distinguish it from our artificial intelligence. So artificial intelligence will be a model of thinking and AP builds a model for emotion for our robots. Next, we come to the end of the section. Artificial intelligence techniques are revolutionized problem solving across various domains. From machine learning and deep neural networks to natural language processing and computer vision, these techniques have demonstrated remarkable capabilities. Their application ranging from predictive analytics and personalized recommendation to autonomous system continue the reshape industries and enhanced efficiency. Thank you.